I know we have enough to worry about here on Earth, but in the case that aliens do come into contact with us, do we think that we'll be able to communicate and understand each other when we start talking about our knowledge of physics and math? In other words, will our physics map onto their physics? Or will they have such an alien understanding of the universe that there's really no mapping and it'll reveal that something about our physics is innately human? So these are the sorts of questions that Dan Whiteson is here to talk to us about today. So stick around. You're listening to Why This Universe, a podcast where we break down the biggest ideas in physics. I'm Shalma Wegsman.
And I'm Dan Hooper. Welcome to Why This Universe. Today we have with us Daniel Whiteson from UC Irvine. He's a physicist there. He worked at the LHC and the Atlas detector. He was involved, he played his part in the discovery of the Higgs boson. And more recently, his physics has involved some novel ways to try to study cosmic rays. In addition to his exciting research program, Daniel's a prolific science communicator. He worked for a long time with this cartoonist, Jorge Scham, and they produced several highly accessible and yet not at all watered down books about physics. I loved them. And then those two launched a podcast, Daniel and Jorge Explain the Universe, which ran until last year. And since then, he's been doing a new podcast with Kelly Weinersmith called Daniel and Kelly's Extraordinary Universe. And then we're talking to Daniel today about his new book that comes out this fall. So thanks, Daniel, for coming on Why This Universe again.
Thanks very much for having me.
All right, so your new book has a great title, Do Aliens Speak Physics? You know, it has this beautifully disarming way to set up the problem, but it's actually full of deep ideas. So let's just start by, giving you a chance to explain the premise of the book. I don't think anybody thinks we're going to meet aliens one day and they're going to have books that look like my textbooks on physics, same symbols, same jargon, whatever. So what do you mean with this question, do aliens speak physics?
Yeah, well, I like to fantasize about the day the aliens will arrive because I hope that they will come. And when they do, I hope that they have been spending billions of years worrying and thinking about the same kind of questions that we have, and trying to understand how big is the universe? Where does it come from? What are its fundamental elements? All these things that you and I and everybody in the field have been trying to figure out. Because the idea that there are answers out there and somebody has them and they could just share them with us is so exciting. And, this is an exciting idea. And there's this feeling in physics that when the aliens arrive, we'll have some issues, figuring out symbols and language. And of course, we don't imagine, like in Star Trek, they will look like us, but with, wrinkly foreheads, or they will rapidly be speaking English. Obviously, there are some cultural differences, but there's this broad conception that at the heart of it, we're going to have physics and math in common with them. And, Carl Sagan famously said, they live in the same universe as we, and so they'll have this in common with us. And, this inspired the design of the Pioneer plaque, where he wrote, didn't use language, of course, but he used sort of symbols to convey these ideas, thinking that some alien scientist is going to get this thing eventually and look at it and be like, oh yeah, that's a hydrogen atom, or, oh, he's talking about pulsars, etc. And I always felt that's exciting, but it's also kind of flattering. It puts us at the center of the intellectual universe to say the problems we're solving are universal ones. The answers we're arriving at are answers that would be recognized and accepted around the galaxy. And we'd love for that to be true, but it felt to me like sort of a trend. Historically, we tend to put ourselves at the center, literally at the center of the universe or at the center of the solar system. And so this to me, I thought this needs a little bit more of a skeptical analysis. And, if you speak to physicists, they're all very confident that aliens are doing string theory or quantum field theory of some sort. But if you talk to philosophers and linguists and anthropologists, they're much more skeptical. And a lot of these questions, is what we're doing universal, Or is it more human, which I think is brought into a sort of a concrete question when the aliens arrive and we want to talk to them about it. These are questions that philosophers have been debating for a long time, and there's a lot of really good work and really thoughtful examination of sort of the foundations of what we're doing that can give us hints about whether they are universal or whether they are human. And one of the goals of the book was to try to bring out some of that work in philosophy and in linguistics and anthropology, which explores these questions, I thought, in more depth than I'd ever seen treated in a popular science book, or frankly, that are often discussed in the halls of physics departments. And so for me, this was like an effort to, like, let's dig into this argument and let's make the strongest argument we can that physics isn't universal, as an exercise to see, like, where are the cracks? Where are the holes? How do we know that what we're doing really is something we can talk to aliens about?
So let me play the Carl Sagan role for a second, and I'll I'm not sure where I come down on this question yet. But I'm going to pretend like I'm sharing Carl Sagan's view. And I look at our universe; it's got a lot of hydrogen in it.
Mm-hmm.
Hydrogen is like the most abundant element in the periodic table. If I depict what hydrogen behaves like in some mathematical things about hydrogen or something like this, I would think I would have pretty good reason to think that an alien who understood what I was doing at all would recognize that and be able to map that onto something their own super advanced civilization once figured out.
Mm-hmm.
Is it, give me the counter.
Sure.
What's the other way to think about that? How, presumably they know, like, how to do stuff with hydrogen. I mean, you can't build spaceships without knowing how to manipulate your world.
Mm-hmm.
So how do you get to a point where you understand how to manipulate and use something like hydrogen without being able to, like, write down facts about it?
Sure. So there's a lot of different directions there. Let's start with the first. Let's assume that the aliens are scientific and they're thinking about hydrogen, etc. They have all that in common with us mentally. And it's just a question of, like, do these symbols that we've written down inspire those ideas, connect with those ideas in their minds? And, if you look at written language of any form or spoken language, it's all symbolic, right? You're taking this idea and you're expressing it into some sort of symbol. That symbol means something to you. But that symbol is always and must be arbitrary and cultural. We write down this depiction of the hydrogen atom, and on the Pioneer plaque, it's like a little dot with another particle orbiting it, right? That's not even the way that we think about hydrogen. It's a cultural snapshot from a certain moment, like actually kind of a very narrow window in human science.
There were like 20 years that people thought that way.
Yes, when people thought about electrons as orbitals. And yes, it's kind of stuck, and you still see it in popular science. But would an alien, even one who has exactly the same scientific view and history as us, as unlikely as that is, sit down and write the same symbol and therefore be able to recognize it? If you look at our experience in decoding human languages, ancient human languages, we're not that great at it. And these are folks who lived in the same earth and dealt with the same experiences and share our biology. Yet it was very difficult for us to, like, decode Egyptian hieroglyphics. Without the Rosetta Stone, we could have been struggling for centuries. And even with the Rosetta Stone, it took 20 years after they found the Rosetta Stone to learn how to decode hieroglyphics, because they made a bunch of incorrect assumptions about hieroglyphics work, and it led them down the wrong path. So the chance that an alien, even one who are identical to us scientifically, gets these symbols and somehow those symbols have the same meaning to them, resonate with those ideas, I think that would be extraordinarily lucky. And that's not even touching on the questions of, like, do they do science, and do they do the same kind of science as we do? Do they see the same part of the universe? Just in the question of communication, it's quite difficult. I mean, for those who are skeptical, like, there are ancient human languages that we still haven't decoded, like Etruscan. We have lots and lots of examples of Etruscan writing, and they lived at the same time as the Romans. We have descriptions of Etruscan culture, but no Etruscan language has ever been decoded, even though it was written by humans fairly recently, and we have lots of examples. So I think we underestimate the difficulty of translating arbitrary cultural symbols into these concepts in our minds and overestimate our ability to write what we think are universal symbols, but are likely just expressions of where we are in a cultural moment in ways that we have difficulty seeing because we're inside that cultural box.
So when Carl Sagan, thought that, we could all fundamentally speak the same kind of quote unquote language, I don't think he necessarily meant right away or like instantly recognize it or something. But that given enough exposure and stuff, we would be able to find ways in which how we expressed the laws of physics map onto the ways in which they express the laws of physics. And I think that's true with like ancient Egyptians too. Like if we had a bunch of ancient Egyptians sitting around and we could, spend time learning hieroglyphics from them, we would fundamentally be able to understand hieroglyphics, right? Or any other human species. Are you proposing that there might be a bigger barrier with something non-human?
I think there are bigger barriers, but let's unpack that. I actually did this experiment. I took the Pioneer plaque and I showed it to a bunch of grad students here at UCI who are young enough to have never seen it before. So they were like, what is this?
First of all, explain what the Pioneer plaque is for any listeners who don't know.
Sure. The Pioneer plaque is a plaque that was put on the Pioneer probe, which is just sent out into deep space and is currently, exploring the edges of the solar system and eventually will, maybe hit some other solar system. And it has on it...
It's like 100 AU away or something now, right? Yeah.
And it has on it a plaque designed by Carl Sagan, and I think also Frank Drake contributed and others. And it's got on it a couple of hydrogen atoms depicted as a nucleus and a proton. And it has a proton, and it has the electron depicted as, a dot with a line showing a spin up, and another version of it with a dot and a line showing spin down. And the difference between these two is supposed to represent like a unit of time. It's the time it takes for the spin flip transition. And on it, there are also dashed lines indicating pulsar fingerprints and distances from them, etc. So you could find sort of a way to locate where our solar system is in the galaxy. But I just showed folks this hydrogen depiction. It's two circles with circles around it, and they're pointed different ways, and there's a line between them, and it says 1. And this is supposed to define like what is a unit of time. And, these are biological humans in the same universe, thinking the same physics as us. And I gave them 2 hours to sit there and ponder it. And nobody got anywhere close. And you're right. If we received an alien relic, we would spend more than 2 hours on it. We would spend 1,000 years puzzling over it and trying to figure it out. Right. But the challenge, I think, is deeper, is that we don't even know if we get the answer right. In order to translate something, you have to be able to recognize when you've translated it. It's like if somebody sends you a code and you transform it or you try to break it, you can tell you've done it when it turns into something recognizable. But we don't know what is recognizable, what the right answer is. And so translating is much, much more difficult. That's why most of the book actually is digging into a different scenario, not when we receive an alien message, which many linguists and philosophers think would be impossible to translate without any sort of cultural context, but instead think about alien arrival. As you say, if we sat down with Egyptians, we could probably figure it out. But just with their writing, we were probably stuck. But if aliens arrive, then we have some sort of physical context in common. We can point to an apple and say, apple. And we can do it again, and they can do it again. And, this sort of method of connecting the arbitrary symbol with the thing we're talking about, I think there's a language, there's a recipe there, an algorithm for building a common experience. If, again, we have that common experience, if we share some sort of mental concepts that we're trying to connect through these symbols. But I think that there is definitely skepticism to be had about whether we think about the universe the same way as aliens, not just how to figure it out and how to make those connections between the ideas in our minds.
This seems, in my mind, to connect to the philosophical question of whether like mathematical or logical concepts are something that human beings create or discover. Like, are they there before we come up with them? Because if we discover them, then it bears to reason that aliens would discover many of the same ones we've discovered. But if we create them, I mean, I don't think anybody on another planet has written the same catalog of songs that the Beatles do because they're creating those songs, they're not discovering them. But, if I think that math is something we discover, then they probably have something that maps onto trigonometry and something else that maps onto, whatever branch of mathematics you want. What do you think about this?
I think you're exactly right. That is the question that the book is fundamentally asking. Though it's funny, originally that's the book I wanted to write. Is our physics universal or is it human? Have we discovered it or invented it? And I actually pitched that to my 14-year-old at the time to get a sense of like, would this be fun? And he was like, yawn, boring. And so I said, all right, well, what if I wrote a book about aliens arriving and then we try to figure out if we have science in common? And he was like, ooh, I would read that book. And I'm thinking to myself, it's the same book.
Yeah.
Because you're right. And this is fundamentally the question I wanted to ask. And math is a great way into that because on one hand, it seems very powerful. Like I'm sure you've both had the experience when you see a beautiful bit of math and you're like, wow, it's so effective. It can't just be describing the universe. We've revealed the source code. This is the way the universe decides where that electron goes, right? It feels really like math is so powerful. And we have so many beautiful moments in history where math has led somebody to a physical discovery, right? Like the symmetry in Maxwell's equations. He's looking at the equations and he's noticing, wow, there's a lot of symmetry here between electricity and magnetism, but there's a missing piece. This would be so much more symmetrical if this one piece was there. And so he added the piece in and went out and discovered, displacement current is real, right? Symmetry leads to discoveries. And, symmetry is deeply interwoven in particle physics. So that gives us the sense that, wow, this must be something that's really in part of the universe. It's very compelling. But the foundations of this mathematics are kind of murky. We don't actually know if mathematics is just extremely useful or if it's actually necessary. Like, is it really part of the universe or is it just a cute trick that we've developed to make these calculations easier? And I read this amazing book by Hartree Field. He's a philosopher. And he argues that math is very powerful, but not necessary. His book is called Science Without Numbers. And he argues that we use math and we use numbers as a sort of way to organize our thoughts. For example, to do intermediate calculations. And a great example of this is the concept that we rely on in all of particle physics, which is the concept of a field. We have this idea of a field like a number at every point in space, or a vector, or some sort of mathematical construct at every point in space. The simplest one perhaps is like the gravitational field. You can feel the force of gravity, but you can also, before you calculate the force, calculate what the gravitational field is everywhere as a way of letting you later then calculate the force. But the thing about fields, that we talk about them as if they were real and we treat them as if they're part of the universe, is they're not something you can directly observe. Nobody's actually ever seen a field. Like, you don't detect the gravitational field, you see the force on an object. So Hartree Field went through this exercise of saying, could I build a theory of gravity without a gravitational field and without any numbers at all? Right? So there's no numbers in his theory. There's no ways you store a value. Everything is built on relationships between stuff and behavior of space and time. And it works. I mean, you can calculate stuff in the sense that you can predict, these things are going to pull together and you have comparators, but you have no numbers. And it's not like a very effective theory. Nobody would ever use it to explore the universe, but it's just sort of a demonstration that perhaps math is just useful. It's not actually necessary. And of course, this is an open question that people who think this is totally bananas in philosophy. But, because we don't know a lot about the foundation of mathematics, where all these ideas come from and exactly how they work, it is an open question. And it's something we should wonder. Is it actually necessary? And is it possible aliens do science not without math, but with some other sort of mental shortcut that they find tremendously effective and can't imagine anybody doing science without?
So I would have described that other thing that, they use for quote unquote mental shortcuts to whatever, think about something. I would just call that a new branch of math. It might not be a math we've used, but the philosophers of mathematics more than a century ago, worked out that logic and arithmetic can be directly derived from one another. They're just two different languages of doing the same thing. One is numbers and one doesn't. And they did something similar with geometry. So like we've done it, well, we haven't completed the proofs, but there's good reason to think, I think, that you could hypothetically do the same thing with, group theory and topology and et cetera, et cetera, et cetera. So imagine there's yet another category of ways of thinking about relationships logically, rationally between different objects, broadly defined. We've never thought of that. They have, but it's still math, right? It's just a math we don't know about yet, haven't discovered yet.
Yeah, that's a fun question. Like, what can you call math? But there's also a really interesting philosophical question there of like, say the aliens show up and they have a totally different way to think about the universe. We use fields, they use schmields or, whatever it is. And then we can ask, look, if our theory is great at predicting particle physics numbers and their theory is great at predicting their experiments, and it's of course assuming we have a lot in common at this point, how do we know which theory is right? And can we tell if the theories are fundamentally the same, right? I think your instinct is to say, look, if it predicts the same stuff, then it's going to be the same. We're going to be able to find a mapping between this one and that one. And we actually have some fun examples of that in our own history, right? We have like wave-based quantum mechanics and matrix-based quantum mechanics. And those two German dudes hated each other and wrote hilarious put-downs in literature about each other. But then von Neumann comes along and is like, hey guys, look, let's all play nicely. I can prove these are the same thing. And that's cool. But there are also other moments, like we have Hamiltonian mechanics and Lagrangian mechanics, two slightly different approaches to describing like how things move under constraints and with forces. And philosophers are still arguing about whether these are equivalent or not. Do they have exactly the same concepts underlying them, or are they two different ways to approach the same problem? And
will you ever make a different prediction using Hamiltonian or Lagrangian mechanics?
No, but that's the question, is could you have two theories of physics which make exactly the same predictions, but tell a different story? A story about the sort of invisible workings of the universe, the concepts that tell us why things happen. Imagine you lived in a Newtonian world where you couldn't access relativistic scenarios, but you had Newton's story and Einstein's story, and they basically agreed all the time. How would you tell which is correct without being able to access relativistic scenarios? Because they tell very, very different stories, right? One is like there are forces. The other one's like, no, there's no force of gravity. And so that's the question that a lot of philosophers are digging into is it possible to have two completely different ideas of physics that make the same predictions, but cannot be mapped onto each other somehow? And that I think is fascinating, because I've always assumed that if you come up with a description of the universe, it's got to be unique, right? Like there is one truth. There is something that's really happening out there that tells us and that determines what's going on. But if it's possible to have two stories about what's happening that make the same predictions but are conceptually different, then that sort of shatters that confidence. It suggests there might be lots of different ways to describe the universe, and which one is true? Do we even know what true means in that context?
Coming up on Season 1 of Crew Collective, how storytellers are telling stories about space. Now streaming wherever you get your podcasts or at crewcollectivepodcast.com.
It's a wonderful thing, and if you get a brilliant idea and you can make it into something that contained, that's great, and then it's one and done and you move on to the next one and you can do something completely different. You get the option to absolutely flip it on its head the following episode. You could do something in a completely different style or a different method of storytelling.
So like the philosopher of science, Quine, I don't remember his first name, but he had this underdetermination of theories argument where he said that any set of observations you could ever have can be explained by an infinite number of different theories.
Exactly.
And like some of them will be just arbitrarily different or like not important in a very significant way, but others will be very, very, very different. And that's just like guaranteed. That's true with us. That's true with aliens. It's true with anything else. And I guess I would argue that for the same way that we tend to, agree on one being the most useful way to talk about something because it's usually simplest and whatever, probably a different alien society would reach similar conclusions. After all, if you just had a bunch of ad hoc elements to a theory that don't make it wrong but make it just more complicated without any upside, it's hard to see any society like wanting to include that. Am I missing something there?
Well, I mean, I think you're assuming that you start from the same place and take the same road, and therefore end up with the same result. You could start from a very different place and invent very different sort of abstract concepts like fields, to describe the universe and come up with, I think, a different theory. But this is an open question in philosophy. And there's lots of folks who feel very strongly like if it makes the same predictions, then it's the same theory dressed in different clothes. And other people who say, no, the underlying story could be totally different. And we're constantly overthrowing our own stories, right? From Newton to Einstein to whatever's next in quantum gravity, replacing theories with something else. And so how could we be confident that our current story of the invisible workings of the universe is the story or the last story or the only possible story? It's not something we know. And I think one thing that would be super convincing is if you had some sort of like recipe to take a theory and generate an alternative theory that makes the same predictions, but is conceptually different and as simple. And nobody has that recipe. So we don't know if it's possible or not. But I think your instinct to say like, but wouldn't they end up at the same place? I think that shows sort of, obviously our preference for the way we think about things. We've been marinated in it. But, it's possible to imagine alternative histories, even of science here on Earth. The way that our science ended up where it is depends on so many random turnings of fate. Dude leaves uranium salts on a photographic plate over the weekend accidentally and decides to develop the photograph for no really good reason and discovers radioactivity and, leads us down the road of quantum mechanics. It could have happened a century earlier, right? Could have happened later. So many examples in our history where our science depends on basically random events. And I think we could have ended up somewhere else. So there's no guarantee, I think, that aliens follow those same random events and end up in the same place and end up finding the same ideas natural or reasonable.
In the book, do you talk about dualities? Do you like, ADS-CFT and things like this as different kinds of theories that could ultimately be different descriptions of the same thing?
Yeah, and dualities are wonderful because, as you say, you have two theories, but you can map them from one to the other. And I love this trick where you can this calculation is too difficult in this theory. Let's go to the other theory, to the calculation, and then map back. That's beautiful. But, that's an example of two theories which are fundamentally the same. They're just expressed in different languages. I think that to me, the more interesting question is is it possible to have a theory which really is just conceptually different? And I like to think about what would happen in that scenario. I mean, imagine aliens come and they do have a theory of Schmields. Maybe some humans would be like, oh, I never really liked the idea of fields, but Schmields, that really connects with me. I'm going to go work on the alien idea. And some aliens are like, wow, I kind of like this human physics. It might be that some kinds are just appealing to us. There's a lot of subjectivity, our feeling, our sense, our intuition that determines what we do and whether we are interested in something and excited about something, whether we find something beautiful and natural. And we don't like to talk about that a lot in physics because we like to think about physics as universal and objective. But, even as a human scientist, what you decide to work on is what tickles your curiosity and interests you. And all of science is just a bunch of humans following their own subjective, personal, cultural, kind of arbitrary curiosity. And so there's no guarantee that aliens end up at the same place.
We as humans, who are the only people we know who have theories of science, we all share the same biology and we've all been on the same kind of environment. And I guess there's also this question, right? If you had something with this totally different biology, would they develop a totally different physics? And I guess I've been thinking this whole time of the story Arrival, which I hope you've seen or read the story by Ted Chiang, where for people who don't know, humans come in contact with a species of alien who I guess like experience some sort of like weird like circular causality or something. I don't really remember the actual idea behind it, but it's like reflected in their language, which is not exactly their science, but something about their logic, right? And so by learning their language, the researchers in this story start to like see the world in their way. And I know there's like, that's a pretty out there version because it's like this story, but I wonder if you talk about that or if you think about how different planets and environments might have developed different kinds of life and whether that would mean like a totally different relationship to physics.
Absolutely. And Arrival's a great example of how difficult it can be to break out of your assumptions. And you're staring at a puzzle and you can't solve it because you started from the wrong place. And I think that exercise is really valuable. And that's exactly the kind of thinking that inspired this whole book. And in the book, each chapter where we dig into like a question about how aliens might be different, we start with a little fictional vignette to imagine in a concrete term, like, okay, what would it be like if aliens didn't use math, or if aliens didn't do science at all, or if aliens had a different theory of physics? And we sort of put together a first contact scenario to give people a taste of that. But yeah, we dig into that in detail. Like, imagine, for example, you have aliens that don't have the same distinction between where bodies end. Imagine aliens that exist in the atmosphere of stars. They're, some sort of plasma beings, and, where Shalma ends and Dan ends is not so easily defined. And so perhaps their mathematics looks fundamentally different. Maybe they don't come up with integers because counting 1 and 2, what do you mean 1 and 2? Where does 1 end? And actually, if you turn that back and look at ourselves, like, it's not so well defined philosophically, even for humans. Like, where does my body end exactly? Is it the surface of my skin? Does that include my nails? What if I cut them off? Does it include my personal space? Like, it's a little bit arbitrary and cultural. I say this is Daniel and this is not Daniel. And there could be aliens that it's obviously more fuzzy, and that could certainly affect their mathematics. I spoke to a philosopher of mathematics who said a lot of really fascinating things about whether aliens are likely to do arithmetic. Because first I asked Noam Chomsky, I said, hey, how would you speak to aliens? And he said, you got to start with arithmetic because that's going to be something in common. And then I asked a philosopher of mathematics about it, and she's like, well, I don't know if arithmetic is something they will have in common. Even here on Earth, humans have very different relationships with the basic counting. Dan, you were saying that all the foundations of mathematics is counting. Well, counting is even still kind of cultural. Like, if you toss a bunch of stuff on a desk and you ask somebody, how many things are there? They might just say, okay, there's 7 things. But if you ask like a Japanese person, they count differently. They say, oh, there's 4 long things and 3 flat things. And they wouldn't ever put those together in the same category. They're not the same kind of thing. You count them differently, of course. And that's a cultural difference, right? What you consider to be the same. And you might say okay, there's 10 apples on the desk. If I ask you, how many things are there on the desk? You could either say, oh, there's 10 apples, because you recognize there's a similarity between them. They belong in a set we call apple. Or you could focus on their differences and be like, well, there's this apple and there's that apple and there's this apple. It doesn't make any sense to put them in a set. And so there's a lot of cultural arbitrariness in how you think about these things. And that's at the basis of integers, which is at the basis of arithmetic, which is the basis of all mathematics. And so there's a lot of interesting things to explore there. But also in terms of alien biology, like how they perceive the universe. We only see a tiny slice of the universe, as you both know. We don't see dark matter. We don't see dark energy. We don't even see neutrinos. And so if we had a different set of senses because we evolved in a different environment, then we might start from a very different place in building our theory of the universe. Or imagine if we were microscopic. And somehow aliens were microscopic actually, and they could interact with quantum objects without collapsing them, right? What if they could perceive a photon when he was in superposition, right? What's that like? I don't know, but it might be a lot easier to come up with a theory of quantum mechanics when that's intuitive. And so, maybe they don't struggle at all with quantum gravity. They figure that all out because it's obvious to them. And so I think definitely the biology and the environment is very likely to shape how they perceive the universe, which is going to not just change how they explore the universe, but the answers they find acceptable, the things they find intuitive. I mean, we ask questions till we get to a point where okay, that makes sense. That's a point when you stop. And, that where that point is depends on what you find intuitive, which depends a little bit on, your experience of the universe.
And what about science itself? So by, we're setting up a premise where society has enough technology to reach Earth. So this is a technologically advanced society by fiat. Did they have to do something that we would call science to get there? And I guess, by which I mean using something that we could call the scientific method.
Yeah, I don't know. I think it's obvious that something like science as an engine to make discoveries is very powerful and accelerates technology. But, even here on Earth, and again, all we can do is look at our example here on Earth and extrapolate. But even here on Earth, we have a long history of being technological before we were scientific, right? Like, how did we make cheese? How did we make beer? How did we make bread? We had no idea what was going on microscopically, but people knew how to do it, right? There were all these technologies we developed, how to make swords super sharp and durable. Nobody knew the solid state physics of how those atoms were lining up, but they knew if you do this and then you dunk it and then you do this, we could do these things. And so obviously, these things are vastly accelerated by having a model of the universe and building on it through empirical exploration, obviously. But if you have 1 million years, could you become spacefaring? Could you show up on Earth with warp drive technology without knowing GR or being able to explain to us how it works? To me, that's a super fun concept that aliens show up and we're like, wow, tell us how warp drives work. And they're like, I don't know what you're talking about, but here's how you build one, And so in the book, I actually went through a hypothetical example of how aliens might get there. And obviously it would take a long time, but I think it is plausible. And you bring up the question, Dan, of could we call what they're doing science? We have this sort of story in our minds that I hear a lot, that science is something that sort of popped up a few hundred years ago, thanks to Galileo and Bacon deciding, hey, we should do some experiments. We shouldn't just think about stuff. That's the sort of cartoon version of it. But the real version is that it's much more gradual of a process. The ancient Greeks, they were doing some experiments. The Arabs were doing some experiments. The Chinese were making observations. People were confronting their ideas to the universe. And so what we call science is not like, here's one idea. It's something which itself is evolving, is changing. And so what we call science today is one thing. What we might call science in 1,000 years could be very, very different in 1 million years. And so it could be that aliens show up and they're not scientific at all. They don't care about why. Or it could be they show up and they're doing something which is very different from our science and far superior, right? They might look at us and be like, how could you not think to add XYZ to your process? Right? The way we look back at people who didn't do experiments and say, well, why didn't you just go out and test this in 10 minutes? You could have known the answer, right? And so I think what we call science is also very cultural and very political. And, the job of being a scientist, this is a word that didn't even exist until the 1800s, being a professional scientist. And so do they have folks who do this for a living? Do they have institutions like these? They're all very, very cultural questions. I would be shocked if we had any of that sort of cultural infrastructure in common with the aliens.
So I'm picturing, some ancient peoples figuring out how to brew beer or something. And there were probably some accidents. There were probably some observations. They probably tried some different things and saw what worked and repeated until they got pretty good at brewing beer. That sounds like science to me. It's not super formalized and it's maybe not the most distilled version of science, but it's still science. And then it got a little more distilled in the Age of Enlightenment and all that stuff, and a little more distilled in the modern era, and it will continue to be distilled. But at least I can't wrap my head around the idea of making technological progress without doing something that involves observations, trying different things, learning from those quote unquote experiments, and refining your views about the world. And now it might not be all the way down. Like you said, you don't know what the microscopic origins of fermentation are or whatever. But the science isn't necessarily about fundamental science. Science can be applied science, So I don't know. I can't picture it without something I would call science, but maybe I've just expanded science to be so big that almost anything qualifies.
Yeah.
Yeah, I actually have like maybe a follow-up thought, which is I wonder how different the question is for math or for like just purely abstract logical thinking, like apart from specific like arithmetic or something. Like it feels like human history is a lot of abstraction. And maybe perhaps there's an alien species that's like totally living in abstraction, or maybe there's one that has no abstraction at all and is like totally just, putting things together and seeing what happens.
Yeah, exactly. I think these are really fun questions. What exactly do we include in science? I mostly agree with you personally, Dan, but I wrote this book as an effort to like steel man the other side of it. So let me take that position. I think I would say that what you describe is a sort of walk through various recipes. How do we make the tastiest cheese? How do we build the best sword? Whatever, as a way of like tweaking through various steps. But what I think an essential part of science is understanding it, is developing a model for why did this one work and why didn't that one work? And therefore, what's more likely to work in the future? And rather than just randomly exploring stuff and seeing, does it work? Is it tasty or not? I can predict which ones are more likely to work, and I can design those things. And that's the real acceleration.
Using generalizations.
Yeah, exactly. Yeah. And also there's a curiosity, like, when your bread didn't turn out, you want to know why. Is it because I put it in the sun, or is it because I didn't put it in the sun? And what's really going on? And that really is the question of the book, is like, how much of this do we have in common with aliens? How much do aliens wonder why? Because that has got to be cultural. That is part of being human for sure. And I can't imagine living in this universe without wondering why. But, there's lots of folks, humans, walking on the surface of the earth who don't care at all about what are the fundamental elements of the universe. To me, that's mind-boggling. They're as good as aliens, because to me, it's the most obvious, important question in the universe. But obviously, other people have different interests, and that's fine, of course. And so you try to extend that to aliens, like, yeah, they could be very curious about different things or just not curious at all. So I think that essential part, the building of a model and trying to understand, that comes from a curiosity. And I'd be amazed if we shared a lot of that with aliens. It'd be wonderful if we did, but I'd be sort of amazed if we did.
I wonder at all if you talk about whether aliens would make art, because it feels tied to if we're like abstracting and wondering about the world and asking questions about the world, that you would also be kind of pushing boundaries and making things or something like that, or if that's would be a measure to you.
Yeah, that would be amazing. I think it already tells you a lot about people, right? If you enjoy the same art, if it touches you, if it moves you, it tells you you have something in common with them. And so in the same way, art could tell you like whether we have something emotionally connected to or conceptually connected to aliens. I think that'd be fascinating. Like, would you respond to alien art? Would they even have that sort of concept? I have no idea. It's a great question.
Daniel Whiteson is a physicist at the University of California, Irvine. His new book with Andy Warner, Do Aliens Speak Physics?, is out tomorrow, November 4th, 2025. Check it out if you want to dive even deeper into all of these exciting ideas. Why This Universe is produced and edited by me, Shalma Wegsman, and my co-host is Dan Hooper, a physicist at the University of Wisconsin-Madison and the director of the Wisconsin Ice Cube Particle Astrophysics Center. If you want to support us, consider subscribing to our Patreon for as little as $3 a month. And in return for your support, you get ad-free episodes and the ability to ask us questions directly for Ask Us Anything segments. You can find that on patreon.com/whythisuniverse. Thanks for listening.